Welcome to the third day of the Fennoscandian Exploration and Mining Conference 2021. We will kick off this day with the student online event. My name is Eetu Jokela and I'm a project geologist from Finland Oy, and I also represent the Finnish Mining Association as one of the organizers of this very event. Few things about the technical things of this session first. If you see a little lag in the stream, click the right corner of your stream and you can set down the quality of the stream, and that should help. Also, we have the chat box on the lower right corner. Please use it for comments or questions to our speakers. And you can send the questions all the way through our show. But to our program, first we will have the welcoming words from our student event organizers, Sondre Stenvold Simonsen. Sondre Stenvold Simonsen is a trainee at the Norwegian mineral industry. Sondre is on a 2-year trainee program arranged by Norwegian mineral industry. Currently working at Rana Gruber, looking forward to also work at Sibelco Nordic and Norsk Steen. He is a former student at the Arctic University of Norway with a master's degree in geology. Unfortunately, Sondre couldn't join us today, but he sent us a video welcoming. So please, Sondre.
Hey everyone, and welcome to the student online event of the Fennoscandian Exploration and Mining Conference 2021. My name is Sondre Stenvold Simonsen, and I represent the University of Tromsø as one of the organizers of this session. For those who are here for the first time, Fennoscandian Exploration and Mining Conference, or more familiarly FEM, is normally organized every second year at Levi, Finnish Lapland, but due to the current situation, we're online this year. Either face-to-face or online, FEM gathers together all major mining and exploration players working in Fennoscandia. This conference gives a throughout insight what is going on in the industry right now, as well as where we're heading in the future. We all know that metals and minerals are a crucial part of modern society, and that we will need plenty of new mines in the near future. At the same time, we are globally struggling with crises like climate change and biodiversity loss, and to be honest, mines haven't always been the most environmental friendly. But on the other hand, the whole mining sector will be part of the solution by creating new, better ways of finding, mining and processing our much needed materials. At least, this is what I've been studying during my university studies with my student buddies, and the best way to change things is from inside of the industry. Students have attended FEM already for 10 years. To celebrate this anniversary, we got this amazing opportunity to plan and organize our own session. Here today at the student online event, the focus will be given to topics which interest the future professionals the most. What kind of opportunities do the students have in the industry? Can the industry evolve to become more environmental friendly and socially more acceptable? What are the means to achieve that? In addition, there will be topics that reveal how, for example, geoscience are taught today at the universities. Is everything already fully online now? How about the future? Or what kind of tools are included in the future professionals' toolkit after they graduate? These questions and many more will be addressed during the next few hours. So I hope you all enjoy this session, and thank you.
Thank you, Sondre. And we should go to our next presentation. Next we'll have Laura S. Lauri from LKAB Sweden to present what happens in Norrbotten, opportunities at LKAB. Laura S. Lauri is a geologist with more than 20 years experience working in academia, government organizations and industry. An English petrologist with a master's degree and PhD degree from the University of Helsinki, Finland. She has worked with various subjects including crustal evolution of Fennoscandia, uranium geology, mining regional collaboration, and most recently, iron oxide apatite ores. She currently works as the section manager for field exploration at LKAB in Kiruna, Sweden. Welcome, Laura.
Thank you, Eetu. So, I hope you all can see my screen soon, and then we'll start by looking at what happens in Norrbotten and how do you students and new graduates come into this whole picture. So first of all, some small numbers about LKAB to present our company to you. We are the largest iron ore producer within the whole EU, and as such, pretty large player here in Europe, although globally we only cover some like 2-3% of all iron ore produced annually. But despite that, we are still the world's second largest supplier of iron ore pellets in the seaborne market. So there we are pretty big. LKAB has been around quite a while. So the company was established in 1890, and it's totally owned by the Swedish state. So we 4,500 employees of LKAB all work in the northernmost part of Sweden. And it's really up here where everything exciting happens. We have 2 large iron ore mines that are underground, the Kiruna and Malmberget mines. And in addition, we have in the Slopovar area 2 open pits in operation and 1 in care and maintenance. So even though the headquarters of the company are in Luleå in the Baltic coast, still everything happens pretty much above the Arctic Circle. And LKAB is not only mining. So even though that's our kind of core business and start of the mining value chain, then all our mine sites also have a processing plant. So everything that goes out to the ports in Luleå and Narvik are actually produced iron pellets. So we add value to what we do, not only raw materials, but processed products. So quite a lot happens here up north. And LKAB is very large employee here in northern Sweden, and totally supports the towns of Kiruna and Malmberget. As a company, we know that we need to change to become even more sustainable in the future. The global climate warming affects us, and that's why we have decided to take some processes that lead us towards a more sustainable player in the mining industry. And that's why we have now started quite a few activities that are going to lead us forward to this. And in the following slides, I'm going to go through what we are now and what we aim to be in the future. LKAB started originally as a producer of hematite fines. And since then, we've moved on to producing iron ore pellets, which are a much more advanced way of treating the iron and moving on at the value chain. But that's not quite enough. So recently, we published an intention of getting rid of the pellet production in the coming years and moving to producing sponge iron, and not only producing sponge iron, but producing climate-friendly sponge iron with no carbon dioxide involved in the process. So LKAB has now put together a project called Hybrid together with SSAB and Vattenfall, so that eventually we will move from pellet production to sponge iron, which is reduced by hydrogen instead of coal. In addition to iron production, we are now looking into what else we could do. So LKAB as a total also includes production of industrial minerals. But we also are mining iron oxide apatite ores. So we do know that we have quite a lot of phosphorus in the ores that we are already working with here in northern Sweden. And that's why taking this phosphorus out of the mine waste is actually something that would be sustainable. So LKAB has also launched the project called REMAP, where we are looking into becoming a phosphate producer, because that appetite that we have is pretty clean. So we could be able to produce fertilizers with very low contents of harmful elements like cadmium. And moreover, what's possibly even more interesting is that the apatite contains quite a lot of rare earths. So getting those out of the ores that we have would actually give us quite a nice coverage of the annual rare earth need of EU. But the REMAP project is still in a very pilot stage. Some of you might have listened to the presentation on Tuesday about it, but this is also something that's coming up and quite interesting, not only from a geological point of view, but also the processing and market. So we are aiming to widen our scope even there. LKAB has already actually managed to produce first fossil-free iron sponge earlier this year. So 2 years ago, one of the existing pelletizing plants in Malmberget was rebuilt to use bio-oil as the fuel. And this year, the first sponge iron ingots were produced there, totally fossil-free, not yet carbon dioxide-free, but we'll get there in the end. And this is something that's currently being developed quite a lot to be able to reduce the carbon dependency. LKAB is also looking into renewing the mining, because right now LKAB's iron mines are pretty much the only large underground operations where we mine for magnetite. And we aim to become independent of diesel engines and move to electrical vehicles, more automated mining, which reduces the need of people to be in the dangerous areas. So quite a lot of effort is also put into renewing the whole concept of mining. And like I said, there's this iron producing with hydrogen technology, which is one of the branches of development we're looking into, and also this extracting the critical materials that the European Union needs from what we can get out of the ground. So there's a lot to be done. And as for the carbon dioxide, we know that we need to go down. Steel industry is in itself a very large contributor to the carbon dioxide problem. So the plan of LKAB is to actually reduce the emissions by 35 million tons, which equals 2/3 of the Swedish emissions. So succeeding in this one is definitely going to be not only very important, but also very good for everybody. So what we need to do to be able to do this? Well, we need to find more ore, because what the exploration department is doing actually is crucial for the development of the LKAB and all these projects. And coming from the exploration department, I kind of both feel the responsibility, but also the excitement about working in LKAB, because like I said, the company has been around for over 130 years now. And if we in exploration do our job properly, then we might be able to celebrate the 200th anniversary of LKAB in 2090. And right now we are already looking into what happens past 2060. So LKAB is thinking long term. That's why also telling about LKAB to the students is pretty cool, because it will be you guys who will continue the work. In the recent years, we've invested heavily in exploration. So in the past 3 years, the exploration department has grown from I would say 25 people to over 50, and we are still recruiting. And we've been drilling a huge amount in these past 3 years, and actually managed to lift both the amount of mineral reserves and resources in all of our mines. And the work is not done. We are still doing a lot of exploration within the mine sites, but more and more we are going to move out to the greenfield, and that's going to be quite an interesting journey to take in the next 10 years, I would say. And LKAB is still recruiting geologists, so keep your eyes open. All in all these activities that we are now doing is going to create a lot of jobs in Norrbotten. So we are investing in the next 15 to 20 years about 10 to 20 billion Swedish crowns per year. And especially this investment phase provides a lot of jobs. And I hope I will see some of you who are now listening to join this iron train. It's going forward. But how to get in? I'm going to conclude by presenting some opportunities for the students and the new graduates that we have at LKAB. So even during your studies, I think most of you nowadays have this internship requirement in your degrees. And there's a good possibility that if you want to do your internship at LKAB, then it's entirely possible. We have a lot of students coming in, and it can be anything from just a few weeks to up to maybe 6 months time. And when you are an intern at LKAB, usually you get no salary, but you do get accommodation in the mine site. So it's not like you have to come here and sleep in a tent. No, we take care of you. And even though there's no salary paid for the interns, then we strongly encourage you to see the funding opportunities that you can get through your university. And we support these Erasmus Plus applications and such if you are willing to look into those. So there's always a recommendation letter coming up from LKAB. So even during your studies, it's a very good chance to do your internship here. And so you get to know the company, you get to know the job. You might even get a chance to get a job. We also support Master of Science projects. So all in all, there's something between 20 to 40 projects funded every year, with a wide scale of branches from geologists and engineers. And this gives a good possibility of really getting into a real life problem and solving it and looking into it. So at the LKAB website, there's a page where you can check these options, both about the internships and the Master of Science projects. And of course, we offer a lot of summer jobs. So also that information is found in our website. There's a lot of need every year. So keep your eyes open and apply for us. We also have a special dedicated trainee program in LKAB. And right now I wanted to take this up because the application period is still on. And so you should submit your application until the 5th of December this year. And the trainee program is intended for those who have just finished their studies, either at the bachelor or science level. And mostly it's focusing on engineers, but also economists. And I don't know if geologists as such are part of this trainee program, but it's entirely possible to apply. And the trainee program gives the opportunity to work for LKAB for 9 months. And after the program has been finished, you have a job. So there's a program that includes a number of mandatory blocks. So you get to see the whole company, work with different teams in different areas, and also do a site visit outside Sweden. Hopefully when the COVID is over, this is a much better chance then. But anyway, you will visit all the mine sites and work with different people within LKAB. And our goal is to develop future engineers, future LKAB employees with a good competence and knowledge about what we do, and also to improve what we do in the future. So LKAB warmly welcomes all of you students in our group, and I hope to see many of you applying for these positions, internships, master's projects, and everything else. Thank you.
It was an excellent presentation, and we got a few questions.
Okay.
Pirjo wants to ask, I have heard you have young employees from Japan, Britain, Norway and Finland. Who teaches them Swedish? Are they expected to know the language when they enter Kiruna, or are they taught there?
Actually, the exploration department currently has over 20 nationalities within the group. And when people come in from Chile, Japan, other European countries, they are not expected to speak Swedish. It's definitely an asset if you can speak Swedish or Norwegian, but English is fine as long as you have a good level of English. And we are paying for the Swedish course for our employees. So even though you didn't know a word when you came in, you have a chance to learn.
Excellent. There was another one from also Pirjo. Do you admit take in employ people from Finnish vocational secondary education institutes, even if their language skills are not that great in Swedish?
Like I said, Swedish is not the requirement, but I would strongly recommend all Finns to use the knowledge that they get in school, because it's certainly good if you know some Swedish. I'm myself a Finnish-speaking Finn. So, but currently, after a couple of years at LKAB, I'm pretty much fluent in Swedish, English, and Finnish, and use them daily.
Excellent. Okay, and one more from Pertti Lamberi. Do you pay a sort of master science fee once the student has completed that is sometimes called as writing reward or kirjoituspalkkio? If not, I think you should.
Yes, actually, I'm not quite familiar about what the current policy is. I think, at least for the Swedish universities, we do have that. But I need to check this. What we do is, for example, I had a master's student last summer. So I hired him as a summer geologist. So he actually got a salary and could concentrate both on his master's study and do some work. And I'm glad to say that he defended yesterday, and I'm kind of hoping to get him back to Sweden now. He's from France.
Awesome. Great. Thank you for your presentation and the answers. And I think we're gonna move to the next presentations.
Thank you, Eetu.
So, thank you. Next, we will have Roger Hamberg from Geological Survey of Sweden. And his presentations will be about the methods to minimize negative environmental effects from mine waste. Roger Hamberg has a PhD in the topic of mine waste treatment and has been working at the Geological Survey of Sweden for 3 years. At the SGU, he is leading projects regarding mine waste treatment reclamation at closed Swedish mine sites, tutoring in international training programs, and participating in various research projects in cooperation with international researchers and universities. Hello, Roger. Can you hear us? I think you are muted, but...
Yes, could you hear me now?
Yes, now we can hear you.
Could you see my presentation as well?
Yes.
Okay, good. Then I'm going to start now. So first of all, I'm very happy to be here. I'm looking at Swedish mine sites. There are 13 mines in operations. Last year we generated about 90 million tons of ore and about 110 million tons of waste. And we have over 100 closed mines in Sweden, and the accumulated amount is over 3 billion tons. So looking at the introduction of mine waste, as we all know that mines are often located in an unspoiled nature, and in these ore, the cut-off grades is in the range of percentage per ton regarding base metals or 2 grams per ton regarding precious metals. But these grades are really has been descending during these years, and these IBA metals are often associated with sulfide minerals in the ore. And as if of millions of tons is generated each year, they need to really be handled in an appropriate way to avoid the future environmental damage. So looking at enrichment processes, they are never 100% efficient. There's always a presence of non-valuable or valuable residual sulfides in the waste. And the oxidation of these residual sulfides could mean that you generate an acid mine drainage with high contents of metals and sulfates and acidity as well. So how should you do about that? First of all, before you plan your mine waste treatment, you really need to know your waste. And to know your waste, you need to perform some extensive characterization. And for that, you might want to use, or you want to use, methods that could identify and quantify these acid-generating or buffering minerals in your waste. But the general sense to do that could be hard to detect small amounts of metals and minerals, and also to detect secondary amorphous minerals that are quite important for the regeneration of acid mine drainage. And it's also has been a lot of research going on about the interpretation and the way to scale up this standard prediction test about acid mine drainage generation. But for doing that, it's absolutely vital to have a representative sampling campaign, because you want your samples to be conforming with your waste that's going to be generated in the future. And for that matter, this is only an equation that is used by the Swedish Standard Institute, but this is when you have no prior knowledge of your waste. So looking at the prevention of acid mine drainage and metal release, you can use a lot of methods to prevent this. You can either remove your oxygen or remove the sulfides by applying a water or soil cover, or by applying a desulfurization step in your flotation circuits. You can neutralize the generated acidity by liming, which is quite often that you do that by adding lime, so you precipitate your metals into metal hydroxides, or you enhance your metal stability by adding lime in combinations with iron precipitates, which will absorb and co-precipitate your metals onto or with these iron precipitates. But the choices you make should be based on what kind of environment you have at your final storage. Where are you supposed to store your mine waste? Are you going to store it in a permanently water saturated way with no oxygen, or are you going to store it in some other ways that you need to think of before you plan your mine waste treatment? So looking at mine waste treatment during operation, and for this matter, waste rock, then you know that the waste rock is the material that is removed to reach the ore to be transported to a permanent storage facility. But you also know that this waste rock, there could be large large surfaces that could be exposed, because these sulfide minerals are occurring in veinlets. But you also should know that when you are dumping this waste rock in your piles, the larger boulders go to the bottom of the bottom of the pile, and this really facilitates oxygen entry into these piles. It could cause an extensive sulfide oxidation. And the possibility to handle that is you can have some co-disposal. When you co-dispose waste rock and tailings, kind of filling the voids. You can also do pre-sorting the waste as well, to pre-sort it into a non-acid generating part and then potentially acid generating part. And you pile them up onto each other, so you have a net buffering capacity within your piles. You can also mix lime in your waste dumps and also perform some backfilling so that the waste is to be permanently under the groundwater table. So speaking about treating tailings during the operation, you might want to deposit them in ponds. That's the most common way to do it, because you want to avoid sulfide oxidation by depositing your tailings permanently underwater. But that could be difficult, so there's some possibilities to avoid or minimize sulfide oxidation from tailings in this part, where you can sort of form capillary barriers, where you divide your tailings into a fine fraction and a coarse fraction, where the fine fraction is withholding a lot of water through capillary forces, and oxygen is hindered to penetrate into your mine waste. And you can also perform some backfilling or some cell deposit, where you either backfill your waste into underground cavities, mixing it with cement or not to have it permanently water saturated, or you can deposit it into cells when you separate sulfide-rich tailings from sulfide-poor tailings. So, looking at mine waste treatment at the mine closure, we use passive methods in Sweden. We use different kinds of covers, so dry covers and water covers, or a raised water table, or most often combinations thereof. But when we have evaluated these mine closure actions in Sweden, whether or not they have been unsuccessful or successful, they have always been needing to have some complementary actions that, of course, grown over time through better regulation and better knowledge. But there is some need for enhancement regarding waste characterization and water balance that is seldom performed. And the use of dry covers at mine closures, that is quite common to use that in Sweden and in Finland as well, I think. So you should ask yourself, is the oxygen penetrating hindered? You don't want oxygen to penetrate into your mine waste. That's why you're having this sealing layer that is going to withhold a lot of water so that oxygen wouldn't penetrate through it. And you don't want to root penetration into your sealing layer, but that's kind of hard to control. That goes back to that you want a high water saturation within your sealing layer so that the roots wouldn't go down there. And you should also know that when having these actions or dry covers, you need a large amount of virgin materials, such as for the protection layer. There has been some research about using industrial residues instead of this clay till or the soil. But there is some challenges in transport and overall quality. And you must also know that if you are covering oxidized waste, the wash-off for these acid-generating salts could be going on for quite a long time. So you should estimate some need for some complementary actions such as liming or lime points or whatever. So using water covers mine, there's some challenges to that as well. You should keep a water depth above 0.4 meters to avoid frost. And also, if you have covering fresh waste, you can have a diffusion of processed water into the overall water. And again, if you have covering oxidized waste, the dissolution of this acid in minerals could be going on for quite some time. So if you're planning to use or construct a wetland, it's really about to construct artificial wetland by distributing the surrounding water flows. The challenge by doing these actions is to maintain these reducing conditions where you can precipitate your sulfides and provide for a constant organic matter supply. So you have reduced conditions, and you can also want to fix the metals in your sediments so they won't be flushed away during spring flood or high water flows. So looking at some complementary actions in Sweden, and also elsewhere, of course, but we often use some calcite barriers or lime ponds directly adjacent to this mine closure sites or these closed mine sites, with the aim of obviously raise pH in the outlet water to be able to precipitate your metals. But the challenge is in doing those or constructing those is that you have to know about the future metal load and the acidity. For that, you have to do some calculation to predict the contact time between the calcite and the acidic water to avoid clogging within your barriers. You also want to know that the placement and the capacity of these ditches so that they are having the capacity that is demanded in these cases. And you're also creating another waste, this lime sludge. You should also be aware of where to and how to dredge and store these kind of lime slugs. So, for some final remarks is, whatever you do in for mine waste treatment is really to plan and conduct and evaluate whatever actions you will do. You should perform the characterization, and then you conduct it, and then you evaluate it. If it's not good done in a good manner, you go back and do it in a better way. So that's in general what I have to say. So thank you for your attention, and sorry for the technical approach.
An excellent presentation, and we got plenty of questions here. So I'll probably ask you one, and then you can answer the rest of them in the chat window. So because we are running a bit close at the time. But Christina Branterud asks, can you please tell us a bit more of the water balance that you said was seldom used?
The water balance, you should be able to, during the exploration phase, then you can perform a water balance in your area. They are using that to perform a water balance in your area, but when you're closing your mine sites, these water balances will change, because then these open pits or these underground mines, they will be filled with water once again. And then the water balance will be changed. And these kind of calculations and these kind of predictions are seldom made. That's kind of my answer to that.
Okay, thank you. I think we have to move on to the next presentation. So, next one we will have Matti Rautakoski from Oy Kati AB, and with his presentation considering environmental aspect as a service provider in exploration core drilling. Matti Rautakoski has worked at Kati for 15 years, primarily in sales, executing team and the company board. His responsibilities are especially strategic planning, foreign customers and development. He is in the board of partner companies Palsatec Oy and Geovisor Oy, who also operate in exploration and mining sector. Currently, he is studying MBA module at Aalto University. So, do we have Matti online?
Yes, I'm here. Eetu, do you hear me?
Yes, we do.
Great. Hi, everyone. I guess I should be able to share my screen.
Yes, that should be possible. And if you can go to the presenter view. Now we can see your slides.
Okay, good. So yeah, my name is Matti Rautakoski and I am a business manager in Kati. Kati is a drilling company. And today I want to give you an overview of how environmental aspect is taken into account in core drilling, especially in exploration drilling, which often happens in sensitive areas. So yeah, this is a disclaimer just to, I want to remind that this information is not like full complete package in such a short time that we have here, but I want to give you probably some new information and an overview of this matter. And our company in nutshell, as you can see, we have been in the business for more than 40 years. And our main service is drilling core samples, which you can see in the background picture. This is our view, from our point of view, how we see this process of starting the exploration project and ending probably even in the mine establishment. And of course, this is strongly simplified, but it's our perception. And here you can see diamond drilling, which is basically our job, and we are focusing on that part. Drilling is actually why it is so important because it gives you the obvious proof and precise information of what is lying beneath the surface, and that's why it's so important for exploration and mining operations. Our company has been doing work in environmentally friendly way for many decades already, and we have even that ISO 40001 environmental management system in 2004, and since then it's been a very systematic way to improve our operations in that regard. And this work has been noticed by our clients and some other parties as well. This is a picture of how the drilling was like 40 years ago. This is actually our very first rig and very first drill site. And this is how it looks like nowadays. So there is quite a big difference, we can say. The guiding idea, how we are approaching the drilling work is we want to minimize the ground impact. And there are some, we can say, standard minimum level of actions listed here, that we want to choose proper machines, which means they are rubber tracked, they are technically capable to move in the terrain without leaving too much traces and reach the target areas. Of course, we want to prevent any kind of leaks to the ground. To do that, we do systematic checkups, maintenance work, and that kind of work. Tree cutting is something we want to avoid, and we, together with client, often plan the routes beforehand to keep that aspect in mind as well. And obviously, no trash can be left on the terrain. We clean and the sites we leave it. Any excess off-road driving is something that we also want to minimize and avoid, and just stay on the market tracks to minimize the effect to the nature, and stay on the market tracks. Yeah, and finally, we sometimes have to use chemicals in drilling to give a good core recovery. So that's sometimes necessary, but when we do it only when it's necessary, and those chemicals are environmental friendly, biodegradable, or anything like that. We choose always the best in that term. So these measures, among some others, may be sufficient in some of the projects, but there are some more advanced solutions that also can be utilized if need be, and it's especially in nature conservation areas we want to sometimes use those. There are closed water circulation, there is artificial snow, and sometimes even helicopter portable drill rigs. And I'm going to give you a little bit more information later about these. There's some just more of technical nature of measures that we can use is closed fueling supply chain, or we are using it everywhere actually. So it means that the fuel that we are using is transported and handled completely without any contact with open air, and that minimizes greatly the risk of a leak. And we also use biohydraulic oils, which are more environmental friendly than standard type of bio or hydraulic oils. It needs more dense changing interval, but it's better choice. And also the hydraulic hoses that we use, like there is hundreds of meters of hydraulic hoses in each rig, and we choose the ones that are more or stronger than the component manufacturer actually recommends. So we have a little bit more on the safe side. We want to be on the safe side in this matter as well. And the final symbol means that we have also those spill trays and tarpaulins under drill rigs, that if any leak may happen, these will collect all the drops. We can say that even smallest of the leaks, even much smaller than 1 deciliter, is considered as an incident, and it's reported and cleaned proper way. And all our incidents that may happen, including near misses, including observes, are reported digitally. So our client will see what happens instantly. And this is also something that we use to learn and develop our operations better. Now a little bit more about the closed system, closed water recirculation. We need water in drilling process. It's many times it's used taken from the natural water source like lake. It's pumped into hole where it gets contaminated with drill cuttings. and then it returns back from the hole. So in that point of time, the water has drill cuttings in it, and we take it into a closed system container, which is standing next to drill rig, where we can clean and separate cuttings from the water, and then reuse clean water again in drilling process. This actually makes the result is that bedrock drill cuttings are not let on the ground, and it's also means saving water quite remarkably. Well, sometimes the bedrock is not solid, and then we don't get all the water back. So there is then more water usage, but optimal level is even 95% of saving. So this is a typical area. This looks like how the drill site looks, where we are using closed system container. Closed system is this red container right next to drill rig. And I mentioned artificial snow. This is the site where we are making the snow. You can see the snow gun on the background. The picture is actually taken from top of a snow pile. And what's the whole point of making the snow is actually it's sometimes it's a requirement that we cannot enter exploration area without having a proper snow cover that protects the ground. And now when sometimes the winters are not so cold and we don't have not much snow, or snow is kind of delayed, so we can kind of start earlier the winter season when we make our own snow and do our drilling, driving routes and drill paths with it. And it has been quite a good solution in some sites. Since the requirements of exploration drilling machines are quite taken into extremely high level, it's not easy to find a suitable drilling machines just on the markets, on the desk. So we are designing and we are building our own drill rigs. And this allows us to meet these high standards of exploration work, and even develop new solutions and make ourselves better and improve the exploration drilling and minimize the footprint. I want to say that it's just having a plenty of technical solutions is not good enough. So it's important to have a certain mindset when we are operating into nature. There must be constant evaluation when we are taking the next step of moving, again starting drilling, doing some special operations during drilling, on how to minimize impact to the nature in each step. And it is also about respecting the nature and local society who is living nearby. So in my opinion, core drilling is nothing like rambling in the forest with some sort of tanks. It's more like, even though we have big machines, it's more like a sensitive, well-considered exploration work. And I just, you can see these text appearing to the screen. Our employees, they are often people who love nature and are interested in being in the nature. They like being outdoors, and that's one of the points that also makes us good in that regard. And when we combine that with the top class machines, with the company culture and procedures, then we end up with environmentally friendly exploration work. Okay, I want to thank you for your time, and if there are any questions, I'm happy to answer.
Opening presentation. Actually, yes, we got questions for you, and we have time at least for one. Pertti Sarala wants to ask, what happens to used water after drilling? Do you pump it back to lake?
We can actually pump it back in hole or in lake, or we can transport it out of the area. But when it's clean water, we can actually then leave it to the nature back.
Okay. Great. Thanks for your presentations and we also, yes, got another question. Sorry about that. So Pertti Lamberi is asking, Matti, your closed circuit system is essential for sustainable drilling in sensitive sites like Sakatti. When developing that, did you work together with universities? Did you have any students within the team making their thesis work? What about in future, taking students in your R&D projects?
Pertti, actually, it's funny because your company, before you joined in, was a great assistant for us to drive us to develop that system. So that was a good example of how we operate with our customers. We get some input from our customer back more than 10 years ago, and together with them we developed the idea, and then the actual technical solution. We also got help from the connections that our customer had. And we are really grateful for our customers they are also a driver for us to develop our work. And for the second part of your question, we have our in-house engineers, but it's something that we probably would like to consider to have also some help from parties that are not our employees, but they may have some valuable input in developing our systems even better.
Okay, thank you for your answers and presentations. And now we have to get to our next presentation. So next we will have Pertti Sarala from Geological Survey of Finland and Oulu Mining School, and the topic will be the new surface geochemical methods in mineral exploration. Dr. Pertti Sarala is a geologist and geochemist. Fields of interest include quaternary and glacial geology, geomorphology, applied geochemistry, till and weathered bedrock geochemistry, and mineral exploration. He is experienced in glacial processes, mineral exploration, development of surface geochemical exploration methods, and teaching and supervision of the thesis projects. He is a member of the Association of the Applied Geochemistry, the INQUA Peri-Baltic Working Group, NORDQUA, European Geosciences Union, and Steering Committee of the PaleoArc Working Group. He is also a member of the editorial boards of several scientific journals. I think we have Pertti online now.
Yes, I'm here.
Great.
Good afternoon, everybody, and I try to share my screen. Can you see it now?
Yes, works well.
Good. Good. Okay, so I'm talking about new surface geochemical exploration methods, and why I'm speaking about that is the reason is that surface geology and geochemistry is very significant part of mineral exploration and mining projects. And most of the deposits or mineralization which have led to mines have been found based on surface geology and geochemistry, and there are still possibilities to find new deposits based on transported cover. And of course, when we are here in Northern Hemisphere, glaciated terrains are very important, but those techniques are also suitable for other terrains. And exploration is relatively easy and cost-effective using soils. There is also strong historical background in particularly in glaciated terrains to use those techniques, and not only geochemistry but also quaternary geological maps and also glacial formations integrated to exploration. And of course, there are a lot of data available nowadays, but also new sampling and analytical techniques that are supporting exploration. And nowadays, geomorphological mapping based on LiDAR-based digital elevation models is very effective way to look landforms, particularly in glaciated terrains, and those landforms are very indicative when identifying different mechanisms how the material is transported and deposited, but also give good idea of transport distances and directions, how glaciers have moved and how material is moved. And in Finland, we have quite good situation. We have whole country covered by LiDAR, and actually this year, Geological Survey of Finland published first version of geomorphological interpretation dealing with glacial lineations, moraine formations, and glacial fluvial deposits, and that is available in web services of Geological Survey of Finland. And that has increased understanding of the distribution of glaciogenic landforms and also give an idea of glacial dynamics in different areas of glaciated terrain. And we can use that data for understanding genesis of different glacial morphologies, but also understanding secondary transport directions and distances. And as you can see here in very rough version of from northern Finland, how we can use morphological interpretation to identify transport distances and directions. And that is very good starting point for exploration work and planning sampling in different morphological areas. And we can also use that, for example, in prospectivity modeling, like you can see here one example from Kuusamo area, eastern part of Finland, where we tested how we can improve tilt geochemical dataset by integrating transport directions and distances there, and we will get much better, let's say, matching of anomalies to known mineralization. And then kind of conventional methods for collecting till samples are handmade test pits and tractor excavated test pits, also percussion drilling. But when we are in the areas where we have very thick glacial overburden or other sediment overburden, then we need different drilling techniques to collect samples from basal part of our overburden. And there are different techniques for that, and we tested several techniques a few years ago in our NovTechX project and found that soil drilling and particularly sonic drilling techniques are very effective techniques for that, and it is also good if you are doing indicator mineral research at the same time as a part of exploration procedure. Then you can collect large basal samples and also make sure that you have reached bedrock surface. So at the same time, it is possible to drill short drill core from the bedrock, upper part of bedrock, which is very good and benefit for whole exploration project. Then, of course, we have a lot of development happened last 10-15 years with on-site analytical techniques, and there are many portable analyzers available. And for example, gas and water analysis can be done directly in the field, but also element concentration using portable XRF, portable LIBS, and also mineralogical analysis using infrared spectrometry, portable XRD, portable Raman, and many other methods nowadays. And there are even mobile phone applications available nowadays, and that field is, if I understood right, it is developing quite fast. And we can use those methods and techniques, for example, in critical metals and minerals exploration, including, for example, battery metals. And when we integrate the different on-site concentration techniques, we can do that very effectively directly in the field, using indicator or heavy mineral indicator mineral separate of the till material or better bedrock material, for example. And we have tested in several case studies, greenfield exploration, but also in old mine tailings area, like in Rautavaara, and found those techniques very useful. And there are a lot of potential to do that with low cost and also environmentally friendly way. And then we have this group of surface geochemical exploration methods, which are not so new technique, but it's a kind of renewed idea of use of them, and there are a lot of sampling and analysis techniques nowadays available for that, and that is based on mobile metal ion migration from the sub-outcrop or deep ore bodies. So metals and hydrocarbons are moving through the soil, and they accumulate those metal ions to the upper soil or then plants and even snow in those areas where we have enough snow cover during winter time. So we have a lot of materials available, different materials available for this kind of surface geochemical exploration. And what is good point, we have very environmental friendly, low impact sampling methods available for that. And it is quite easy and quick to do that sampling. And there are many types of analytical methods we can use for different type of ore bodies or mineralizations, or ore types and mineralizations. And here is one example of the use of snow in gold copper exploration in sulfuric ore deposit. And this is coming from Juomasuo, Kuusamo, where you can see here a couple of mineralization. This is a subsurface deposit, pyrite-rich ore body, and then a little bit deeper blind body. And based on SAG, so spatiotemporal geochemical hydrocarbons, you can see very nice anomalies just over the known mineralization, but also using high resolution ICP-MS, you can see also very nice metal anomalies just over the known mineralization. And we have several other good examples how even snow can be used in mineral exploration. So that was short overview of this surfacial techniques, and if you have now some questions, I'm pleased to answer. Thank you.
Thank you, Pertti. What a great presentations. And actually, I have one question for you. You were talking about the biochemistry. Does it really matter what kind of plants we are using at that method?
Yes, of course it is. First thing is to look what kind of plants you have in your study area. That is the first thing, and then different plants are accumulating or collecting metals different way, and that is important to study first before collecting or starting collect samples.
Okay, thank you. And thanks for your presentation also. I think we need to move on to our next presentations. And next one will be from Tobias Bauer, Luleå University of Technology. Tobias will talk about virtual field exploration course that he has held at LUT. So, Tobias E. Bauer is Associate Professor in Ore Geology at Luleå University of Technology, Sweden. His research includes structural controls on ore deposits and the regional structural and tectonic evolution of mineralized belts. In addition, he is active in the field of 3D and 4D modeling applied to mineral belts, mineral deposits, and related structures. He received a master's degree in geology from Ludwig Maximilian University of Munich, Germany in 2008, and a PhD degree in ore geology from Luleå University of Technology, Sweden in 2013. So, do we have Tobias online?
Yes.
Great.
Thank you. Thank you for the introduction, and hello, everybody. So I would like to show you an example that Corona was not only bad, but also showed us up a way how to actually improve our education and move towards a more digital and, in this case, a virtual way. So we took the opportunity that we were actually not able to go to the field with our students and took an already existing field course in exploration and turned it into a virtual field course. So, and a little bit about the background of this first before I go into the course. So, I mean, you all know geology has a quite traditional approach. We go to the field with our students and we show them the rocks. And geology has already really advanced chemical and analytical technologies and so on. But when we go to the field, we are still actually quite traditional in the methods we are using. And we want to see modern technologies as a tool to improve this really important part of fieldwork. So definitely we do not want to replace fieldwork, but we want to see it as a possibility, to see modern technologies as a possibility to improve this. So for this, we are working with drones, and drones are just one example that we are using. So we have two different drone systems. One is a simple off-the-shelf DJI drone system with a good optical camera that can be used for photogrammetry. It's really lightweight, easy to use, even for a non-professional drone pilot. And the other one is a bit larger system, which can actually carry a lot of weight and different sensor systems. So we're using this for not only optical photogrammetry, but also have a magnetometer to put on, a thermal infrared camera to put on, and so on. So for this course, for this virtual course that I'm going in a few seconds, we are using the principle of photogrammetry, which is actually quite simple and not so modern technology anymore. This has been used in the past already with overlapping aerial photographs that were then viewed in a device that you can overlap, and you get a stereo image of this. So photogrammetry is taking this this principle up again, and you have photos taken from different angles, and if you combine them, you will get a 3D point cloud of the object that you were photographing. So it's basically doing the same thing that your eyes are doing all the time. So this includes, so the data acquisition goes as follows. We are planning our flight at home already on a computer. So this is, we're doing regular grids over an area. In an ideal case, we're also putting reference points that allows us to geo-reference our models. You can put up manual fences that you're not flying into objects. And then the drone is flying off it on its own and taking overlapping photographs of the designated area. With the large system, we can then, of course, also add different sensors, but I'm not going into this in this talk. This sounds very simple. It's in an ideal world, it is also simple. In real nature, it's often causing some problems. Elevation models are sometimes not very accurate, so there's a risk that you actually fly into objects, or magnetite-rich rocks are causing troubles with the inbuilt compass of the drone, and then the drone is flying in a different direction than you wanted. So crashes can happen, and you have to calculate with that your drone will sooner or later fly into something that you don't want it to fly in. So you have to climb up sometimes trees and get this equipment back. So once these overlapping photographs are acquired, they can be loaded in a software that aligns the photos. From this alignment, a dense point cloud is built. So this point cloud is then triangulated, turned into a mesh. And on that mesh, you can then drape the photographs onto it. And this will turn out into 3D models. And you can do the same trick not only from drone images, but you can also take handheld cameras. You can take your mobile phone and make overlapping photographs from different angles and stitch them together and turn them into 3D models. So this is what we did for this field course. So we went around and digitized outcrops. So we were scanning outcrops with the help of drones and handheld photographs. So this is an example of an outcrop. You see this is a beautiful tight overturned fold. And the outcrop itself is maybe 3-4 meters high. And you can zoom in. And this is not a field photograph. This is the actual screenshot of the 3D model. So you see these models can be really high resolution. So we are talking about few millimeters in resolution. This is definitely good enough that you can actually go in and measure bedding, foliation, and certain features in these rocks. So these are 3D models that can be then shared and communicated. So we were utilizing these technologies for setting up a virtual field course. So as I said before, the course already existed, part of an EIT raw materials master program called Explore. And the teachers are Niels Jansson and myself. And the course is meant as a run through the entire workflow in exploration. So we go through structural mapping, volcanic fascias mapping, alteration mapping, drill core logging, and in the end, generating a target for, or in the end, actually telling where the ore deposit is. So, and everything is applied to volcanic hosted massive sulfide deposit. So the actual field area of the course is here in the Skellefteå district in northern Sweden. So this is a volcanic arc hosting plenty of volcanic hosted massive sulfide deposits. So massive sulfide lenses within the volcanic edifice. So, and we went around and digitized basically outcrops in the field and took 360 degrees pictures and videos that students can go in. They can walk through the field and explore these 3D models. And I prepared a video for you. This is how the one module in the course looks like. So you have 360 degrees videos. Students can go around and scroll around and get a feeling of how the landscape actually looks, especially for students from abroad that are not so used to it. You can go in and actually have a look at the 3D models. So this one is taken from a drone. And we also embedded lecture videos, as you would get when you are in the field with the teacher, a lecture on certain geological features. So these videos are embedded at some key localities. So you can click on it, watch the video, go to the outcrop and so on. So once you then identified your key outcrops, students can open these high resolution models in open source software called Cloud Compare. And there you can take structural measurements. So this shows you the 3D model with textures, but also the 3D cloud, point cloud model. And I also prepared you a video for this. So you can simply measure structural elements in such a model. So this can be done by digitalization. So these are, for example, digitizing a layer in this layered gray vaccy here, utilizing 3D effects of an outcrop. And so by digitizing, you can then create such a trace on the 3D model, and that trace can then be used for creating a surface, and that surface then represents the bedding in this place. So this is in principle replacing your compass measurement in the field. These 3D models are georeferenced, so you will get a real orientation of that surface plane. And that can be directly plotted in a stereo plot, and you will get dip direction and dip of this surface. So that was the structural mapping part, but the next step would then be to map volcanic fascias. So you see that these photogrammetry models are definitely good enough to actually see textures in the rocks. So students are mapping different volcanic fascias and determine where they are in the volcanic stratigraphy. So defining which is the ore-bearing horizon here, where do we have coherent volcanics, where do we have the clastic volcanics that are important for hosting the volcanic massive sulfide deposits, where are the sediments, and so on. So reconstructing the volcanic stratigraphy in this area. Additionally, we added geochemical analysis that we had from previous work. Students get access then to this geochemical analysis, and that pretty much like you would do when you're out doing exploration, also looking at the outcrops, taking samples, getting a geochemical analysis from it. So students are then looking at the geochemistry and creating this alteration maps and defining which rocks are more altered and which rocks are less altered, and combining this into a picture. And then they can tell where they want to put a drill core or a drill hole in the ground. And Boliden had drilled the area before, and they provided drill cores for this course. And the drill cores were scanned by our Explorer. So we have 3D tomography scans. So these are computer tomography scans of drill cores. So actually 3D images of this that you can turn, and you can look at structures, you can look at textures, you will get chemical concentrations on this. So you do pretty much digital drill core logging on this. And all of this is in the end then combined into targets. So by the end of the course, the student should be able to put his or her finger on the map and tell, here is approximately the deposit. And so basically an entire field exploration workflow within distributed over a few weeks. So this is all set up in different models that students can go through basically in their own pace. So the look ahead, we don't want to stop there at virtual reality actually. And we are in the moment working on augmented reality. We would like to be able then to take these models back out in the field. So in the ideal world, this would be a hybrid course. So first step, virtual. So, and once you understand the systematics, you go out in the field and look at the rocks with your eyes and touch the rocks and get a feeling for the rocks. And augmented reality would be a good opportunity to actually take models then out in the field. So we are experimenting in the moment with like this Microsoft HoloLens, where you can actually then project an ore body into an open pit or take a model out in the field, and you can see the reality, but the models will be projected into this. So there are exciting projects going on. This is examples from the Farming project, but we also have then this next generation SIMS project going on, where this virtual field or this virtual technologies are playing an important role, especially for educational purposes. So with that, thank you for your attention, and contact me in case you have questions.
Thank you, Tobias. Actually, that was so interesting that even I would like to attend your course. But we also got a few questions for you. And Lauri asks, what kind of feedback have your students given about the virtual field course?
Yeah, so far, good. I mean, the very first time we were setting it up, there are, of course, technical issues. The entire technology is new and so on. But so far, the feedback was really good, and I think it's a very pedagogic way of teaching this. My honest view is that the virtual course does not replace a proper field course. In an ideal world, this is given together. So first the virtual part and then going out in the field and looking at the rock. So I want to be really clear that virtual world is not a replacement for the real world. But I think it's a good and powerful tool to as a complement.
Excellent. Also, one thing that popped in my mind was that do you think that we could do these models without those expensive drones and stuff? Because the new iPhones, for example, have the LiDAR technology in them. So could we use like our phones for that?
And we are actually already doing this. So a normal outcrop, you can take photos with your smartphone, and they are definitely good enough to make photogrammetry models. And as you say, the iPhone 12 and 13 have the LiDAR scanners, and they are definitely good enough to scan outcrops. And we are in the moment experimenting with this, and the results are good. So the general trend is that we are going away from these expensive technologies, also virtual reality. So nobody needs to buy virtual reality headsets or large 3D screens anymore. You can do a lot with augmented reality in your smartphone.
Excellent. Thank you for these answers and excellent presentation. And I think it's time again to move on with the program. So next we will have a panel discussion with the topic of the future of online teaching and learning in higher education. And at the panel, we have moderator Dimitra Pitsa, who is part of the FEM student event organizing team. Dimitra Pitsa is highly motivated master's student in exploration and environmental geosciences at Luleå University of Technology. She has been involved with geology since 2015 and obtained the bachelor's in geology from the University of Patras, Greece, with specialization in exploration of mineral deposits or an economic geology. Her 4-month undergraduate internship took place in the Hellenic Survey of Geological and Mineral Exploration, while her bachelor thesis was a petrographic and geochemical study of the third bauxite horizon in Parnassos Giona unit, Greece. She has great interest in exploration of critical and battery metals and rare earth elements. Currently, she is studying about the critical metal occurrences in southern Sweden. The second member of the panel is Sabina Strmic-Palinkas. Sabina received her PhD degree from the University of Zagreb, Croatia. In 2013, she moved to the University of Auckland, New Zealand, for a 2-year research fellowship studying ore-forming processes in low sulfidation epithermal gold systems. Since 2015, she has been affiliated with the Arctic University of Norway in Tromsø as an associate professor in ore deposit geology and geochemistry. In 2019, she joined KG Jepsen Center for Deep Sea Research at the University of Bergen, Norway, where she holds an adjunct position in ore geology. Her principal area of research is geochemistry and of hydrothermal ore deposits, including mineral chemistry, fluid inclusion studies, stable isotopic geochemistry, and thermodynamic modeling. During the past 20 years, she has been involved in studies of a wide spectrum of ore deposits, including epithermal, kaolin type, hydrothermal metasomatic, skarn, SEDEX, MVT, and pegmatite deposits, as well as in several environmental studies. Recently, she is mostly working on submarine hydrothermal systems along the Arctic mid-ocean ridges and volcanic massive sulfide deposits, organic gold deposits, and sediment-hosted copper deposits in Norway. The next panelist is Glenn Bach from Luleå Tekniska University. Glenn Bach is a senior lecturer in ore geology at Luleå University of Technology, Sweden. He has worked for 20 years with organic gold ore deposits, specializing in microanalysis of gold ore textures applied to ore genesis and exploration. Lately, however, his research concerns trace element byproducts in ores and geological storage of CO2 CCS, carbon capture and storage. He received a master's degree in geology from Gothenburg University, Sweden in 2002, and later a PhD degree in ore geology from Luleå University of Technology, Sweden in 2008. From Finland, we have Professor Pietari Skytta from University of Turku. Pietari Skytta is a structural geologist primarily interested in solving and modeling the geometry of the complexly deformed crystalline bedrock and its evolution through time. He has strong experience in field geology, both in research and teaching. The student member of our panel is Emma Flodin, who is also a member of the FEM 2021 student event organizing team. Emma Flodin represents Luleå University of Technology and currently is studying at the master's program in environmental geochemistry. She has a bachelor's degree in earth sciences from Uppsala University from 2017. And currently, she's working part-time as a research engineer in soil mechanics at LTU. Also, she works part-time as a team leader at Science Center Teknikens Hus. I think we have all panelists online, so welcome and go on.
Hello, and welcome to this panel discussion. I think that we have slides with the questions. Oh, might not. Anyway, we can start with the first question, and the format for this discussion is gonna go first Sabina, and then Glenn, Petteri, and then Emma, and each one of you will have about 1 minute to answer its question. Okay, so first question is about, as we're living in a changing world, the higher education must also keep up to date with the growing demands. Have you experienced that the quality of the classes has increased or decreased due to online teaching? What about student learning outcome?
Yeah, thank you for the question, Dimitra. So I would say that there is no really like anonymous answer to your question. And I would say that it highly depends on the size of the classes that we have, depends on the level at which students have been found during when pandemic started. And of course, it always depends on the motivation of both teachers and the students. So with some courses, especially when we have smaller courses, I would say that we can see even increasing quality of teaching, but it can be very challenging for starting years of study programs. So for instance, our students at bachelor program, our students at the first year of bachelor, they really struggled from several reasons. So it was not only a thing of teaching. So we could, of course, we managed to convert all our physical classes to online teaching. But what we really miss, especially with students that just came to Tromsø, to Northern Norway, they were missing the social component. And we found that it's sometimes very difficult to motivate students in these challenging times. But again, we found also some quite positive things with online teaching. And you can see, for instance, the example that Tobias just gave in his presentation, we could really implement online and digital tools to improve our teaching and to increase the outcomes from our classes. But yeah, sometimes it can be very, very challenging. Also, what I would like to emphasize that we found is extremely positive in online teaching, that we can combine teaching, we can offer our program not only for students that are physically sitting at our campus, but also we can involve more international students. And students, no matter where they are sitting, in Northern Norway or somewhere else, they found that kind of very motivating, and they found that very positive. So in many cases, we are inviting students from other universities to join our regular courses in Tromsø.
Thank you, Sabina. Glenn?
Yes, thank you. I will start with saying that I totally agree with Sabina, and it's been sort of an up and down kind of journey through this pandemic and still is. And I would say that when it comes to increase or decrease in the quality of the classes, I think both have been what we experienced here. We've taken sort of a huge step when it comes to using digital tools, which is good for us teachers. But some teachers have adopted quite easily, whereas some have struggled quite a lot. So we have seen some decrease at the university level when it comes to the throughput of the students. But there is also a large variation between different departments. The mining department here, for instance, is at sort of a status quo. We haven't seen a decrease or increase here, but certain departments have seen a slight decrease. And I think in the long run, it's the teachers and the students sort of adopting to a new situation. It takes a little bit of time to sort of to weather the storm, so to speak.
Thank you. Peter.
Okay. Hi, everybody, and thanks for the invitation. It's a pleasure to be in here. So quite same lines of thoughts, I think I would say, with Glenn and Sabina, but I could maybe express myself also in a way that it gave some sort of an initial boost, that it was new and exciting and people were interested, and then it started going down if nothing specific was done, and that was a bit of a challenge to keep up the number of all the existing courses and try to implement them in a new way, so that it's not only going online with the lectures and so forth, but I think there is a lot about activating people, and it was also really, like Sabina told, coupled with the overall uncertainty of the students, what's going on, and is it worthwhile taking any courses or taking a year off or whatever, and that I think clearly was reflected in it. But well, at the same time, there was improved access to some, like world was opened in a way that to those who are interested, they can take whatever the courses are available worldwide. And I would also say that in general, I think it works better in a bit more like advanced status of the studies at the master's level, better than at the bachelor. So those little additions. Thanks.
Thank you. What about you, Emma?
Hi, everyone. And I just want to say that I understand that it was a big struggle for the teachers to go from actual teaching to online teaching. And I think that this was managed generally very well. For me personally, I have had a very good experience with the online teaching. For me, who's not living in Luleå, it was very time-saving to stay at home and follow the lectures. Then I had more time to prepare, looking at the PowerPoints, both before and after the lectures. But that's just for me personally. Although I think it depends highly on which class that you're taking. The classes that would have been better if we would have practical sessions would have been much better to not have online. But since this was not possible, I think it was solved quite good by the use of Zoom, since we could work in breakout rooms, and since LTU at least has available database where you can use different programs. And I think it worked quite well. And if we're going to do more online teaching in the future, I think it will be easier to plan for doing the lectures better. So generally, I had a good experience, but I just want to say that it depended on which class it was and what exercises what was in the class. Thank you.
Excellent, thank you. I would like to encourage our participants to write their questions in the chat, because this is like an ongoing panel discussion. We just have more or less just a few questions prepared. So feel free. And we move to the next question. it is easy for students to hide in an online classroom. Do you think it is only the responsibility of teachers to provide high quality online teaching? And what about students' feedback or students' engagement during classes?
Yeah, so again, I would say it depends, but I would say that here teacher is the person who is in control of the class. I cannot say that teachers are really responsible for learning outcomes because, of course, students are responsible for what they will learn, but teachers have a really great responsibility to organize the classes on way that they will motivate students. And I would say, yeah, it's easy to be hidden, especially if you don't have to have your camera on. But if the teacher at the beginning of the course required camera on during the classes, maybe students at the beginning are not really happy. But what I got as a feedback from my students at the end of the course, they said that they are happy at the end because it was a little bit kicking out them from the comfort zone, saying, okay, you have to have all cameras on. But at the end, they found that quite positive because when you have camera on, you have to be focused, you have to look on the screen. So it gives at least a bit of impression that you're sitting in the normal classroom. So yeah, this is my experience with this hidden and active students. But also I found something that Emma said, these breakout rooms. So of course, when pandemics hit, no one was prepared for Zoom teaching, and even we didn't know what Zoom is. So everything came overnight, but the breakout rooms really saved our teaching because also they serve like a safe room for students. So you can send a small group of your students to breakout room and they can discuss. They can discuss also topics that are not necessarily relevant or related with that particular a topic in the classroom, but also, again, it gives this social component, which is extremely important for outcomes of the whole course.
Thank you. Glenn.
Yes, thank you. I agree, and I think that it takes two to tango a little bit here. I mean, the certain responsibility on the teacher, but very much also on the students to sort of make this a good situation. And it's, I mean, for me as a teacher, it's a terrible thing or experience to give a lecture to a Zoom room which is just sort of full of black screens. There is no connection, nothing at all. And so this is what I also then suggest that keep the cameras rolling while the lecture, but that's not always possible. And it varies a little bit between different classes, different students, I guess then. But the thing that I think is most difficult to get through in an online situation, online tool, is the connection with the students. It's so much harder online compared to standing in the classroom. I mean, if you listen to a speaker who is passionate about their subject, I mean, for me to show my passion for geology is, I mean, me trying to reach the students in the classroom, and then I have just a computer screen in between. I mean, it's no good, obviously. And also one thing is that in the classroom, I probably during a lecture, I walk a couple of 100 meters. I move around a lot. Sitting in Zoom here, I need to sit by my desk and do nothing. I can use my hands and I mean, feet and arms very limited to show what I'm talking about. So this is part of the connection with the students, I would say. And this is not really good. I haven't seen an online tool where this works good in that sense. So I do what I do as a teacher, but I also want the students to sort of put in their part to make this work better, I would say. So again, two to tango.
Yes, totally. What about you, Petri?
Glenn, I can tell you, you can move your hands here as well. So it's all free. Okay, but I think the responsibility is on both parties. So that, but I would say that the teacher needs to be the facilitator in a way that you should try to organize things in such a way that people are interested and they get the motivation. And like listening to what Emma was telling, that you check the PowerPoints beforehand and afterwards. And so if everybody did that, so it would be just very easy to teach, I would guess. In general, since if you have the interest already, so then it's going to be almost necessarily interactive at some level in the teaching sort of the session, since if you are prepared already. So I think in that sense it's a bit tied to some sort of maybe change of paradigm in teaching, that how to get people prepared beforehand, so that actually then when you are teaching, you are just not trying to convey the message in a sense. So maybe that's what I've got to say. But I also agree with Glenn that it's in a way live show when you are doing a normal lecture, that normally if you go into some sort of lectureship or professorship, so you likely have some sort of charisma in yourself. At least you try to build some, that people are interested in listening to you. Thanks.
Thank you. Emma?
Yes, I agree with what all you teachers said, and especially what Sabina said about the cameras. I think it's important to ask the students, at least, would you mind putting on your cameras? Because it actually increases the quality of the class, since then you are more sharp and you're taking notes. And I think that the classes has been better when we have our cameras on. And thinking about the responsibility, I think it's mainly the teacher's responsibility to provide a good presentation and also open for discussions, because sitting online, I know that students like to hide behind the camera or like to not unmute to speak in the Zoom room. But I think, yeah, like Glenn said, like it takes two here, because the students should be asking questions. It's our education and it's not mandatory to be there. So we should be engaged and ask questions, but then also the teachers need to open for discussion or ask if we want to ask something, because in some cases I have experienced that the teachers are just going on with their presentation and not leaving any room for questions. But I've also experienced that the teacher is leaving room for questions and no one asked the question. So it's quite tricky. So I think both perhaps teachers and students can improve on that part. Okay, thank you.
Thank you, great. We have a question regarding this question. Can you force students to have the camera on? What is the policy? From Michael Greenwood.
I don't know, honestly. So, I mean, when you ask students to have that, yeah, you ask them to have camera on, I never receive negative feedback from students that they will say, no, I don't want to have camera on. So yeah, probably if I will have such issue, then I will try to find the answer. But honestly, I don't know what its policy behind. But again, I mean, kind of natural feeling would be if you have normal classes, you have to be visible in the classroom. You cannot sitting behind the wall. So yeah. And when I started with online teaching, in fact, by chance, I was in US, where I was attending pedagogical course for my own education. And my professor in pedagogy there, she insisted that all participants in that course have cameras on. So it was really kind of requirement. So then I literally kind of mirrored that model to my teaching. And I could see even in the first week that I have improvement in the quality of teaching. So yes, I don't know. My students, they haven't complained, luckily, so.
Great. If any of the rest has something to comment on, please go on. It's like
I can say I don't know either what the policy is, and I mean what we can request of the students, other than a polite question of putting the cameras on. I mean, the only times when they haven't put the cameras on is typically that they are sitting on the cell phone on the lecture, and it's difficult with sharing the screen and so on, and using that sort of as an excuse. I don't know, but that's the reason. But I don't think that can sort of enforce anything. But I mean, both parties should know that we need to improve the overall situation, and there will be compromises from both ends. So even if you have a bad hair day, maybe you as a student should turn the camera on. We do as teachers. So
yeah, totally. How about you, Peter? Emma?
I'm not either. I don't really know if you can force anybody to have it, but I think it's a lot better if the cameras are on, so you get some sort of an engagement. But that's not always the reality, unfortunately.
Yeah, and I think it's nice that the teacher asks to put the camera on, because I've seen that in some cases when the teachers don't ask, there is just black screens, or maybe one student who puts the camera on. And I think the students, even though they don't put their camera on, they appreciate to have their camera on, because I know, since I've been talking to the other students, that they listen more sharply to the lectures when having their camera on.
Yeah, staying focused, something like that. I think we can move to the next question, which is, have you found new ways to increase students' interest and commitment to online teaching?
Yeah, so again, it was quite challenging. And of course, we could not keep classical type of lectures where you are talking for, let's say, 2 hours, because students are losing focus, no matter even if cameras are on or off, but to listen someone's talking 2 hours without any break, without any engagement from your side, it's very demanding. So I personally changed the model with more like so-called flipped classroom model, where I interrupt my own teaching, my own lecturing with small tasks for students. So really like putting then active role to the students in working in breakout rooms that kind of decrease this amount of information that is flowing from my side, but also required from students that they take informations actively. And usually what I'm doing in my online classes, I'm asking students that in the groups, they prepare small presentations. So no matter what topic you have, you will get a task that you have to prepare as a group short presentation, and everyone from that group should present, let's say, 1 slide. And this also helps students to learn about each other and to do some kind of teamwork. And again, it kicked out students from comfort zone. But again, as a result of this kind of flipped classroom, I found that my students that had online classes comparing to classical classes, they have much better presentation skills at the end of the course, because they are used to present much often, though it's a really short 1 minute, half of minute presentation, but they repeat that kind of presentation for many, many times during the semester. And I would say that they really benefit from getting presentation skills at the end.
Yeah, that's really good. What about you, Glenn?
Yes, what I think most teachers have done is to put more, questions in the lectures, in the slides, to sort of try to activate the students. And sometimes it works, and sometimes maybe not so good. And I have also in the ordinary slides added then questions, but I also added more sort of discussion slides, sort of a thing where the students can sit and think about a certain topic for a few minutes, and then we discuss this in group, for instance. So I have not used breakout rooms as much, and that's probably on me, because I don't really know how to. So even if we made a transition from sort of classic teaching to online, I still feel that, I have a certain skill in it, but I feel like old school in a new environment, really. So I should probably pick up on the breakout rooms. I know that many teachers have done this. At the university level, we have a pedagogical center, which they act as a support pool, so we can get training, for instance, for online teaching. And all the teachers in the department has also added or set up a pool for idea sharing, things that they have tried and which worked and which did not work, and so on, so we can sort of discuss things and try to improve ourselves, basically.
Thank you. Peter.
Yeah, I've been using also these breakout rooms to, let's say, variable extent, and it's been kind of, I think, quite useful and fun also. Then I put people in different groups, and then I have been myself violently intruding these groups to sort of disturb them and nicely ask some stupid questions to get the sort of discussion running in there. So I think it's been quite useful. And one thing that has been quite good actually is when, for example, getting students on the first year classes, getting them introduced into the different geological data sets available online in an online services like map services. So it's actually been very useful that they have been sitting on the computer. Like if they were in the normal class, so maybe part of them had laptops and so on, but not all. So it's been sort of a natural way to ask them to go to share maybe a link and check this and that and what is available and what is not, and make a little summary on that. And I think also people, it's quite a maybe a little bit more neutral stage for the students to present. Like Sabina, you were telling that it's been, I think, quite nice that they have been improving in the presentation skills, and it feels somehow like the threshold of stepping up on the stage is maybe a bit lower than in the classroom for some people, not maybe not all. Thanks.
Thank you. Emma.
Yes, I really like to have some discussion slides, or where you as a teacher put a discussion slide and then you let's have like 5 minutes to think, and then maybe we have a discussion afterwards. Because even though if you're not gonna conclude with anything yourself, maybe you at least think about this slide or this question, and then you're really interested to know what the correct answer is. But the breakout rooms I enjoy even more, because then you get, as Sabina said before, the social part of the lecture. So even though you haven't asked any questions for the teacher, you at least can talk to some of your classmates and have this interaction. So yeah, I think it's important to add this discussions and breakout rooms to the classes. Thanks.
Thank you all. And we're moving to a very interesting questions. With all these new teaching methods, what kind of opportunities do you see in collaborative teaching and courses between different universities? Could that be possible? What do you think?
Yeah, definitely. So this really brings this component that we can either invite more teachers, because it's time more efficient to have someone sitting no matter where to come to give a course or give a part of course. So we really have now opportunity to invite world leading experts in our classrooms. Also, we have much more opportunities to have shared classes between different universities. So definitely this gives that new component that should improve our collaboration in teaching in both ways, to exchange teachers, but also to put students from different universities, not only from different, let's say, geological departments, but also we can now combine things that are more multidisciplinary, because you don't have to send someone for a whole semester to other country or to other department. It can be just 1 week or 1 day or even just one lecture. So yeah, this definitely, it's something positive that what we've learned from during pandemics.
Yeah. Thank you for being brief. I would like to ask the next three panelists to be brief as well. Please, Glenn.
Yes, I mean, I definitely agree, absolutely. And the sort of low-hanging fruit would be to, as Sabina says, guest lecturers from wherever, and to have them in the courses. The course that I'm running right now, for instance, I have a lecturer from, he will be sitting in Spain giving the guest lecture. So, and also there are, I mean, being developed then much more sort of open access online material that we can sort of easily download and use and sort of try to rearrange a bit to make it our own. But the database on that kind of online material is just sort of adding right now. So definitely I see sort of big potential in this collaboration with, during the start of the pandemic, we had a very good collaboration with Oulu University, for instance, in Finland, and shared some ideas and some material there, because they were a little bit ahead of us. So they were able to help us sort of get started, and it was a very good experience, I think. So definitely great possibilities. Thanks.
Thank you.
I think as well there is good potential. As an example to the sort of an add-up on this previous talk, so I could tell that the Ministry of Education in Finland is funding a project where the different universities and the geology departments are setting up common materials, and that will apply then, that will contribute to some, let's say like 2 or 3 credit points of the full 5 credit point course, so that there will be common content for like some course of geology of Finland or something, like, for example, since every university will anyways be teaching roughly the same content, so why not doing it with the actually exactly the same material and online, and then you can actually put all the effort in the contact teaching and give that with sort of the specs you are having at hand in your own home institution. And I think in the master's level that would be like to broaden the scope of the study, since normally the units are quite small and then the expertise is also limited, so you can like broaden the expertise. Thanks.
Thank you. Emma?
Yep. I just want to say that this is one of the big advantages of online teaching, that you don't have to have lecturers being geographically bound, but they can teach from all around the world, and you can get a lot of knowledge that you wouldn't have if you would have had only on-campus teaching. Thanks.
Yeah, definitely. I think these were our questions. Please, Ed, to tell me if we have time for one more.
All right. Thank you for all of you. I think we actually got one question from Tobias Bauer. And it goes, many universities report an increased amount of students with psychological problems and depressions. Do you see any way how we could react on this frightening development? Anyone?
Please, Sabina.
Yeah, well, I don't have, of course, answer to this. What we have done, at least in Tromsø, but again, it was quite easy, and probably similar things can apply to some of Swedish and Finnish universities like Luleå and Oulu, because we are located far in north. We are talking about small communities, and it was quite easy to control pandemics. We opened our campus, in fact, quite early. So most of lecturing went online, but we had at least one of days during the week when students were allowed to come to the campus and do practical part of their courses in person. So that probably helped, but definitely we have this issue with isolation of students. And as I said at the beginning, it's especially we see a problem with students at the first years of bachelor program, because they are new in the area, they don't have their network, and they're literally stuck close in their student rooms. So yeah, I unfortunately I don't have answer how to improve the situation.
Thank you. Pietari.
I think we could try, but it's also depending on the amount of students that get in touch one by one with these individuals, so that actually you pay attention to one individual and meet them, and even if it takes some time. So, but I think it's been very useful for myself, at least. I've been teaching some courses for the very newcomers who are entering the university. So, and it's also good that then you can at least try to recall their names and faces one by one, and then there will be some sort of connection made. And I hope that will then somehow make the teachers and professors feel a bit more like human beings also to the students, in a sense.
Totally, thank you. Glenn?
If I can add, I mean, we've also seen this at Luleå University then. But we don't really know. This has sort of popped up the past 2-3 weeks, perhaps. But we still don't know if it's at university scale, if it's a big problem. We know of 2 or 3 students who are sort of at a bad situation. But it's sort of difficult for the teacher to act other than sort of trying to refer the student to the student health organizations, things like that. But also I think, because now the teachers are aware of this problem. but also that the rest of the students, which, I mean, most of the students probably feel okay then, that it's important for those students as well to sort of to talk to their, I mean, classmates and try to pick up the signals, because you see the students much more than the teachers do. And if you pick up signals there, that you can also refer them to the student health to sort of help the teachers and then, I mean, bottom line, the students that are not feeling well. So it's I don't know if it's a big problem, but there is definitely a problem. And it's sort of difficult for at the teacher's level to sort of find the proper solution to it. We can do what we can and will, obviously. Thanks.
Yes, I can add some from the student perspective. Now I've been talking from my own experience, and I had a very positive experience with the online teaching, but of course I missed having the socializing with my classmates. I was also new in Luleå, so I didn't know anyone here from before. But for me, it was quite fine, but I have completely understanding that it's really challenging for especially first years to come and only have online teaching. And hopefully this was mostly due to the pandemic. Also, like if we have online teaching in the future, we can perhaps combine it with having practical classes as well, and not only have online teaching. So I think that this was a very special situation. And I mean, there will possibly be future pandemics, and hopefully we will be more prepared. Yeah, hopefully we can help the new students feel better than if we're more prepared. But this was a very special situation, and I understand that it was not easy for the teachers to include the students more than what has been done.
Definitely. Thank you all.
Thank you. And I think we got some questions at the chat, but we have to run along the program. So if you panelists could answer the questions at the chat box after this one. So I think it's time to wrap up and closure. And for that, we have Saija Luukkonen, professor, head of unit from Oulu Mining School. Saija Luukkonen has worked as professor in mineral processing at Oulu Mining School, University of Oulu, since 2015. To her current post, she came from consulting company Pöyry, where she worked in its mining and metal business unit, both in Peru and Finland. During her career, she has also worked for Geological Survey of Finland as a group leader and for Lafarge as project leader. Her background is in physical chemistry, and I think we have Saija online right now.
Yes, indeed. Thank you, Eetu. So it's my great pleasure to be here and take care of this wrapping up and closure. So I was quite amazed that in so short time and so many themes were actually, it was possible to include into this relatively short session. So thank you for that. So first we learned about the mining and needs for the future talents, future professionals, like I was in LGAP, and then about how people and professionals are needed also to take care of the waste, mining waste and tailings. And we learned about the exploration and new exploration techniques, and finally about the teaching, new teaching methods related to the exploration and geosciences. And I have to admit that I really could relate all these discussions during the panel discussion, because, well, let's face it, was a giant leap for all of us teachers to take care of the teaching in the COVID times, especially because we are really all operating in very practical fields, like in geosciences and engineering, in mining. Basically, I was really happy to be part of this student session once again during this FEM, because anyway, so it's so important to get students involved already in these conferences, because for the future, we really need a lot of professionals in the field, even more. Now you all have learned about the green transition and how it actually poses more requirements to the mining industry. because of the shifting demand for the minerals and metals in future, to create green technology and also to assist also the green shift for the other industries. So basically mining and exploration activities are key to everything. And regarding to the students and studies in geosciences and geology, how important it is for the whole mine value chain, thinking not just from the exploration, but also along the value chain and until the tailings management and how to take care of the that all those tailings areas are covered according to the future sustainability requirements. And besides, also tailings can be considered as a potential secondary raw material sources, so in addition to the primary raw materials. So basically, in order to be able to really respond to the future needs for sustainable mining, we need you students, and we really need you to be involved in the very beginning and to create a wide understanding about the whole value chain, because value chain thinking is that is needed more and more in future when talking about the green mining or green industries in general. So I really am happy that these student sessions are organized, and this also enables the networking of the students between different universities and between different countries. Well, that were my words. Not much time for allotted to me for my disclosure, but I think that you get the main point that I had here. In the end, I would really like to thank Eetu for an excellent chair you were during this session, and all the students had actually developed this session and all the topics and themes, that the whole content of the student session of Fennoscandian Exploration and Mining 2021 this year. So thank you all, and thank you for all the speakers, all the participants, and hope to see you in the next FEM. Thank you.